Okay, so now I want to continue with what I discussed before. So this is the fifth lecture. I'm still talking about pressure measurement devices, manometer, and here where I stopped last time. So in the previous lecture, I was trying to get an expression. Okay, so I was trying to get an expression to calculate P1 minus P2 for if the flowing fluid was a liquid or a gas. So I choose the method of saying that I have 2 points. So I choose this point and this point. I set the pressure here is equal to the pressure there, and I solved it, and I got an expression for P1 minus P2. Now I want to get, I want to do the same problem, but by another method. So again, I'm going to do the same thing. So I will say that I will start from point 1, which is here, till I reach point 2. When I go down, the pressure increases. When I go up, pressure decreases. And I want to see if I'm going to get the same answer as I have done before. So I will start. So if this is 1, so I will say if this is 1, so the pressure here is P1. So I will say P1. Then I will go down, let us say from here to here. So if I go down, pressure increases, as you know by now. So P1 plus, so when I go down, the pressure increases by rho 1 G, and this is A, because I go down this distance. And now I will go down more to reach point A. So since I'm going down, so it is plus, but now it is again rho 1 G, and this is H. So now I'm here. So after going down twice, and this is why I have plus and plus. So once I reach this point, now I can say the pressure here is the same as the pressure here for the reasons I have stated many times. So I can have this equal sign. So once I am here now, I want to go to point 2, because this is what I want. I want the relation between P1 and P2. So if I'm going up, if you remember, we said when you go up, pressure decreases, okay? So when I am here, so P1 plus rho, so the pressure at this point plus the pressure at this point plus the pressure here. So now I will go here. Actually, it is not equal. So I am here now. So I will go up. So instead of this equal, I will say minus. Sorry for that. So minus, I am going up. So it will be from here to here is what? Is rho 2. Let me just change this one. It is rho 2 G H. Okay, so I jumped here, then from here I went up, so I have this minus sign, so I am here now, and from here I have to go up again. So going up, another minus sign because the pressure decreases. So I'm going up from here to here, so it is minus, and what do we have? We have rho 1 G A. So I went from here, and now at this point, what do we have? We have P2. So you can say either this is equal to P2, or let me just, you can say minus P2 equal to 0. So from here you go to P2, and that's it, you ended the problem. And now he's asking for P1 minus P2. He's asking for P1 minus P2. So I will just get rid of some of the terms that I don't need here. So I can cancel this term with this term. As you can see, they are the same. This one with negative sign, this one with positive sign. I can take GH as a common factor, similar to what I have done before. So I can write P1, we just change the color, P1 minus P2, which is this, minus this. Okay, P1 minus P2 equals, and I will take those to the right hand side. So it will be rho 2 minus rho 1 times GH. And this is the same result that we have gotten before. So it is either you start, this is what I discussed before, either you start by saying I have 2 points, as we said, 2 points, they got the same pressure. So you go from here to there and from here to there, or you can start from let me just erase all this stuff, or you can start from 1 point. You go down, then you jump, then you go up till you reach the second point. I personally prefer this method, and as you can see, we got the same answer. So again, this is what you see in the slide. So P1, this is the derivation. This is how it was obtained. Okay, this is how it was obtained. This is how it was obtained. We have obtained this equation by the two methods. Now, the question said, what if the flowing fluid is not a liquid, if it is a gas? So if it is a gas, what can we say? If it is a gas, let me just erase this stuff. If it is a gas, then the density of ρ1, this density here, this will be small compared to the density ρ2. This thing will be small compared to that thing. So then, yeah, suppose, for example, suppose this is mercury and this is air. You know that the density of mercury is 13,600 kilogram per meter cube. You know that the density of air is just 1 kilogram, almost 1 kilogram per meter cube. So there is no comparison. So this will be very small compared to this, so I can drop it. And then I can approximate this equation to this form. So P1 minus P2 is equal or almost equal to ρ2 GH after dropping ρ1.